a linear equation. The basic concept is we want to get all the x's by themselves. But before we can do that, we're going to have to simplify. And that means get rid of parentheses. So distribute. The 3x and the 2x is a 5x. Minus 12 minus 7 is minus 19. And then on the right-hand side, I'll get a minus 4x plus 11. Now, if I want all the x's on the left-hand side, I'm going to add 4x to both sides. That gives me 9x. And then we want all the constants on the right-hand side, so we can add 19 to both sides. Now I've got 9x equals 30. And to finish it, we're going to divide both sides by 9. Let's see, 30 and 9 are both divisible by 3. And so I can write that as a reduced fraction as 10/3. You could also write your answer as 3 and 1/3. But I usually leave them as improper fractions. Now in part B, we can do the exact same thing, use the exact same process, except this equation happens to have fractions in it. And most people actually find it easier if you can get rid of the fractions before you solve. And so I'm going to try to find the least common denominator. I have denominators of 3 and 6. And so the LCD is something that's divisible by both 3 and 6. And the answer here is 6. We can divide 6. So I'm going to take the left-hand side and multiply that by 6. And then I'm also going to multiply the right-hand side by 6. So let's see, if we distribute, 6 times 2x is 12x. And then I get a 6 over 3. Remember, with fractions, we just go straight across. So 6 times 1 is 6. 1 times 3 is 3. And we can actually reduce that to a 2. So the left-hand side is 12x minus. Then on the right-hand side, again, we go straight across, and I get 6 over 6, which is the same thing as 1. And so the right-hand side just becomes 1 times x minus 5, or just x minus 5. And now I have an equation that doesn't have any fractions in it. That makes the solving a bit easier. Same concept, I want all the x's on the left. And now I've got 11x minus 2 is minus 5. We can add the 2 to get the constants on the right side. So if 11x equals minus 3, I'll divide both sides by 11. And my answer is another fraction. X is negative 3 over 11. So again, the process was we had to find that least common denominator, and then we multiplied everything in the equation by that least common denominator. And that allowed us to actually reduce things and get rid of fractions. Now, solving linear inequalities is very similar. An inequality might have a less than symbol or a greater than symbol. But otherwise, the concept is the same. You want all the x's on one side. You want to isolate the x. So in example A, let's see, if we want the x by itself, we would just add 4 to both sides. That gives me 3x less than or equal to 12. And just like if this were an equation, I could divide both sides by 3, and I get x less than or equal to 4. Now, what exactly is that answer telling me? Well, there's an infinite number of solutions. The answer is every single number that's smaller than 4, including the 4. And so if I were to draw, say, a number line, this or equal to right here is telling me that 4 is a number. X could equal 4. And then the less than part is telling me my answer also could be anything that is to the left or smaller than 4. We can use the same process for example B. We want all the x's on one side. So let's say I want the x's on the left-hand side. I would start by subtracting the 3x. So 2x plus 10 is bigger than minus 8. And then we can minus the 10. That gives me 2x is bigger than negative 18. And then finally, I'm going to divide both sides by 2. And there's my solution. X is bigger than negative 9. This one doesn't have that or equal to symbol. It's just a bigger than symbol. And so that means negative 9 is actually not an answer, but everything to the right of or larger than negative 9 would be a solution. So this process of solving linear inequalities so far has been nearly identical to solving linear equations. You just have this less than or greater than symbol, which means you have more than one answer. Your answer is an entire interval on the number line. Now there's really only one difference in this solving process, and that would be if you multiply or divide your inequality by a negative number, it flips the direction of the inequality. For example, let's say I was trying to solve negative 2x is bigger than 10. Well, I would divide both sides by the negative 2, but because I'm dividing by a negative number, that's going to take this inequality sign and it's going to flip directions. And now I'm going to get x is less than negative 5. Now we can also have what we call three-part inequalities, and that's what I have in example C. There's 1, 2, 3 pieces to that inequality. The process is the same. We want the x by itself. Now the difference is whatever we do to one part, we have to do to all three parts. And so if I want to get this x by itself right here, well, let's see, we've got to get rid of the plus 1. So I'm going to subtract 1 from all three pieces. That gives me 3 less than negative 3x less than or equal to 9. And then we need to get rid of the negative 3. So once again, we do that to all three parts of the inequality. And now I've got negative 1. And let's see, we just divided by a negative. So that means that inequality is going to flip directions. It's going to be negative 1 bigger than x, bigger than or equal to negative 3. And so what does that mean? Well, once again, if I draw my number line, this is telling me that my answer is bigger than or equal to negative 3. So that equal to means we are including negative 3. And it's to the right, or bigger than negative 3. But it's less than, so not including the negative 1, to the left of negative 1. And so basically my answer is everything between negative 3 and negative 1. Now, we'll come back to the concept of inequalities a little bit later. For now, I just really wanted to do kind of a quick review. Please message me if some of this didn't make sense. But really, the basic idea is you're trying to get the x by itself. And then the one thing you really have to remember is if you're multiplying or probably dividing by a negative, that's going to change the direction of that inequality. So finally, let's take a look at some absolute value equations. So first of all, absolute value means magnitude or distance. In short, if you take the absolute value of a number, it just makes it positive. But basically, what the absolute value is telling you is the distance that number is from the zero, from the origin. So notice negative 3 is 3 units away. Positive 3 is also 3 units away. So absolute value of negative 3 is 3. Absolute value of positive 3 is 3. So if we want to solve an equation with an absolute value, we are going to isolate the absolute value first. That means we're going to get the equation to look like absolute value equals a number. If that number is positive, there's going to be two solutions because we have two numbers, a negative and a positive, that have that same absolute value. But if your absolute value equals a negative number, well, that's not possible. There's going to be no solution because absolute value is never equal to a negative. Absolute value is always a positive number. So let's see how this works with some examples. If I want to solve absolute value of x plus 2 equals 8, 8 is a positive number. That means there's two possibilities. The x plus 2 could equal positive 8, or the x plus 2 could equal negative 8. And then to solve these equations, we would just minus the 2. So I've got two answers, x equals 6, or x equal negative 10. Same process or the same concept can be used in part B, except for this particular equation, we have to isolate the absolute value. The absolute value has to be by itself on one side of the equation. So I'm going to add the 3 to do that. Now I've got 2, absolute value of x minus 3 is 8. And then let's see, we've got to get rid of that 2, so I'm going to divide both sides by 2. Absolute value of x minus 3 is 4. And once again, I have absolute value equals a positive. So there's 2 possibilities. That x minus 3 could equal positive 4, or x minus 3 could equal negative 4. And so to solve, I'm going to add 3, so 7, or negative 1. Those are my 2 solutions. Let's take a look at one more example. Same process, we have to isolate that absolute value. So in this case, that would mean minus the 10. So now I've got absolute value of 5x minus 6 equals negative 8. Now all of a sudden I have absolute value equals a negative number. That's not possible. Absolute value can never equal a negative number. It's always positive. And so when you get to this stage, you can actually stop and just write on your paper, there is no solution. This equation has no solution. So that's it for this first lesson. I know I went pretty quickly through some of these ideas, but I'm hoping you've seen at least some of this before. Please don't hesitate to send me a message if something was confusing, if I can clear something up. But what you want to do now is you can upload either a photograph of what you've written down, of your notes, or if you have a PDF or a Word document, you can upload that into the assignment on D2L. And then you're ready to try the web work problems, and you can move on to that worksheet where you have to show your work. So please let me know if you have any questions about this material. And finally, I want to add, if you hear any noises in the background, it's probably this little lady. This is my dog, Georgie. I make most of these videos at home, so you might hear some barking or squeaky toys, and that's what's going on. It's just this lady needing a little bit of attention. So again, please get in touch with me if something was confusing. Otherwise, you can move on to that web work and worksheet.